Hello everyone, this is KK Matics, the solution to your mathematics. Today we're dealing with bearing and vectors part 2. Illustrative example here. It's important that we solve this question before moving to the subtopic. The first question goes this way. Sketch the corresponding compass bearing of the following three figure bearing. A 250 degrees and B 115 degrees and C is 300 degrees. Solution. Now in consider the solution of A 250 degrees, we know that 250 degrees will be greater or is greater than 180 degrees and lesser than 270 degrees. So since that is the case, that lies in the third quadrant. And if this lies in the third quadrant, that means that would be in between south worst, which gives us south 70 degrees worst. And for us to determine the angle here, just as we said, 250 degrees is greater than 180. The corresponding aspect of that to the three figure bearing, we know that which is what the south is 180 degrees, and that is less than 250 degrees. So the lesser one is normally subtracted from the angle that we want to find, which is the 250 degrees. So if you subtract 180 degrees out of 250 degrees, that gives us 70 degrees. And that's what we have here. Now, let's consider the C here, which is 300 degrees. Now, we know that 300 degrees lies in the fourth quadrant, which is going to lie in between north and west. And that gives us north 30 degrees west. And in order for us to find this 30 degrees, this is done, we know that 300 degrees is greater than 270 degrees. And so for that being said, we have to subtract 270 degrees out of 300 degrees. And it gives us 30 degrees. And so that gives us the angle, not 30 degrees west. Let's consider the B, which is 115 degrees. Obviously, we know that this is going to lie in the second quadrant. So, and that means that it's greater than 90 but less than 180 degrees, which is in between southeast. And so that gives us 25 degrees south, 25 degrees east. How to get 25 degrees is depending on the 90 degrees subtracted from 115 degrees to give us 25 degrees. Question 2. Sketch the corresponding three-figure bearing of the following compass bearing. A, north 50 degrees west, and B, south 15 degrees east, and C, south 30 degrees west. Solution here. A. So in considering here, we know that north 50 degrees west lies in the fourth quadrant. And so obviously we know that three-figure bearing form is measured in clockwise form. So its measurement being clockwise means that what? We'll just have to add 270 degrees to the 50 degrees to give us 320 degrees. So in terms of the compass bearing, where we do the subtraction, when it comes to compass three-figure bearing, we do the addition. So we rather add instead of subtracting, and that gives us 320 degrees. South 15 degrees east will lie in the second quadrant. So that means that we'll have to add 90 to 15. So adding 90 to 15 gives us 105 degrees, sorry. And considering the C, we know that will be in the third quadrant. That is adding 180 degrees to 30 degrees. So that gives us 210 degrees. The three-figure bearing representation here. So you consider three-figure bearing representation. If the bearing of A from B is 300 degrees, then this is represented as, this is the bearing of A from B. It's important to see this way because most students normally make mistakes in considering this. So that's the bearing of A from B. If the bearing of B from O is 30, then this is represented as the bearing of B, that's from O, it's coming from O. And the bearing that you see here is the bearing of B. And remember, it's clockwise. Illustrative example. Find the bearings of I, P from Q, I, Q from P from the figure. So from this figure, you notice that we have a more like a triangular form. However, the bearing of P is beta and the bearing of Q is theta. So for us to determine that, we use the trig ratio, which is SOHCAHTOA, which means that, and obviously with this we'll have to use tan. So tan, toa means opposite over adjacent, which is tan beta equals opposite over adjacent, which is OQ, length OQ divided by length OP, which equals 3 divided by 3, and that gives us, we find the inverse, tan inverse of 1, giving us 45. So then, the bearing of P from Q is 45 plus 270 degrees. And 45 plus 270 degrees gives us 315 degrees. If we consider I here, we have tan theta being equal to opposite over adjacent, the length OQ divided by length OP, which is equal to 3 divided by 3, and we have our theta to be tan inverse of 1, which is equal to 45. And looking at our P, the direction of our P will actually lies in the second quadrant, because the Q that we did lies in the fourth quadrant, whilst the P lies in the second quadrant. And so since it lies in the second quadrant, we're going to add 90 to the theta that we found, which is 45. So 90 plus 45, and that gives us 135 degrees. So that becomes our bearing of Q from P. Reversal back bearing. Bearing of any line measured in the backward direction is known as reversal back bearing. The reverse bearings are useful if you travel to a place and return along the same line of travel. There are two basic formulas for calculating a reverse bearing. One is when the direction of traveling bearing is less than 180 degrees. If, for example, your bearing B is 0.545 degrees, then the back bearing works out to 225 degrees. That is, the back bearing, which is denoted as BB, is equal to 180 degrees plus B, which is the bearing that you started with, which is 0.45 degrees. That means gives us 225 degrees. 2 is when the direction of travel bearing is greater than 180 degrees. If we reverse our example from above, let us say your bearing is 225 degrees, which is greater than 180 degrees. Then your back bearing works out to 0.45 degrees, which is equal to B minus 180 degrees, and that gives us the 45 degrees. In general, if the bearing of B from A is theta, then the bearing of A from B, that is the reversal back bearing, is theta plus 180 if theta is less than 180, or II if theta is less than theta minus 180 if theta is greater than 180. Illustrative example of reverse or back bearing. If the bearing of x from x is 0 to 60 degrees, find the bearing of x from y. Solution here. Obviously, we know that what the bearing of y from x. Remember, it's y, so the direction is from x to what? Y. So obviously, we know 0 to 60 degrees will lie in the first quadrant. But the back bearing of it would be what? 180 degrees plus 0 to 60 degrees, which gives us 240 degrees. That's because what we know that 60 degrees is less than what? 180. So we are to rather 180. You can also find the back bearing by drawing the diagram of the problem using the angle properties of power lines as in the following diagram. So we know that what? Remember, we said what the bearing of y from x. So remember, the direction is okay. This is from x, and this is where y is. So that's the bearing of y, which is 60 degrees. And obviously, we know that if we were to draw this line and draw the directional point or cardinal points here, we know that this will lie in the third quadrant. So we know already that this is a three-figure bearing, so it's measured clockwise. So we measure it clockwise, so that means that it lies in between 180 degrees and 270 degrees. So we'll have to add 180 degrees to the angle here, to the 60 degrees. Remember, just as we said, using angle properties of parallel lines, that means that 60 degrees is alternate to the angle here. 60 degrees, 60 degrees. So alternate angles are equal. So we have 60 degrees. So we add the two. So sorry, 180. Remember, this is the third quadrant. So it's in between 180 and 270. So we add 180 to the 60 to give us 240 degrees. Question 2. If the bearing of P from Q is 245 degrees, find the bearing of Q from P. Solution. So you notice that this is 245, which is greater than 180 degrees. So you then have to subtract 180 degrees from this bearing here. So since the bearing of P from Q is greater than 180, we subtract that gives us 065 degrees. We can also do that by drawing or sketching it and using the angle properties of power lines. So we know that 245 degrees lies in the third quadrant. That's because what is greater than 180 and lesser than 270 degrees. So that being said, we see that in the diagram here. This is the end of the class. Thank you. Please subscribe, like, and share, please. This is KK Mathis, the solution to your mathematics. Bye for now.